Everybody is building for the size that they think they're going to have. They see Google or Netflix or somebody give a presentation about, this is how our architecture works. And they're like, well, this is just how you should build things. I started my career as an engineer and, you can tell the computer what to do and it would do exactly that. You get to a point where you realize, well, in order to really be able to build something bigger than I could just build myself, then becomes a human problem.
It's easy to ignore the noise when the noise is stupid. But when it's starting to wear you down, then that's when you're like, oh, I'm actually burnt out from hearing all these talking heads.
We had this feeling that we were fast. And then people would run benchmarks and we would actually be quite slow. The lived experience doesn't necessarily match the benchmarking experience.
I wonder if we've purposefully, as an industry, created this complexity spiral in a way. And maybe the complexity spiral sells. Well, thank you so much for doing this, honestly. I think that we've been looking forward to chatting with you guys for a really long time, with you specifically, because I feel like we're seeing similar patterns now than you probably experienced when you started MotherDuck, which is there is what everyone is pitching, and then there's the reality of what people actually need. And some of my questions today to you are more around what do people actually need in a database, and as opposed to what companies are telling you what you need.
Right.
And so I guess my first question to you is, you helped build BigQuery at Google. What was that aha moment that made you think, oh, maybe we need to go to small data rather than big data?
It was a few years ago. I was product manager for BigQuery, and I was doing some pricing analysis actually to try to figure out hey, how do we stack up against Snowflake?
Yeah.
And I was kind of trying to bucket our users by size. And one of the things that I realized was wow, most of our users don't actually have a lot of data, and most of our queries operate over very small amounts of data. I think the 90 percentile was sub 10 megabytes of data, which is quite small. And then a couple of years later, I was at Single Store, and we kept seeing customers asking for smaller instances. And we had one that was the size of the smallest Snowflake instance. And they said, hey, can you do something smaller? And so we did one half that size, and they said, can you do something smaller? And we did something half that size. And they said, can you do something smaller? And we're like, no, we can't. We can't make the costs work out. And then I stumbled on DuckDB and realized, wow, with DuckDB, you can really make things virtually any size that you want, because it scales down super nicely. And I think it can also scale up really well.
So you actually answered my next question, which is, do people actually have big data to process and query and store? Or have we, before MotherDuck, were we just building for edge cases in a way?
I think everybody is building for the size that they think they're going to have, or that they want to have, or somebody has scared them into thinking that they're actually going to have. They see Google or Netflix or somebody give a presentation about, this is how our architecture works. And they're like, well, this is just how you should build things. I also think that the architectural designs that were necessitated 10, 15 years ago with the size, and shapes of hardware that we have are no longer necessarily relevant as, servers are much bigger, networks are much faster. And people also realize that, maybe you can throw a ton of hardware at a problem, but that doesn't make it inexpensive. And so they end up, shrinking down the size of data that they need to operate on.
So perhaps is it a use case where the volume of the data was just a product of the circumstances at the time? And as you were saying, if today we have much better networks, much lower latency, faster speed, does it mean that I can process and store smaller bunches of data as opposed to bulk processing gigabytes and gigabytes of data at a time?
Yeah, I think one definition of big data was, something that's too big to process on a single machine. And when people were talking about that, they generally were talking about processing and storing as the same thing. And so once we separated storage from compute, that actually opened up the possibility of having infinite storage, but processing it in a much smaller, smaller tidbits at a time. I might have a petabyte of data that sits on S3, but if I only need to look at, one customer's worth of data or 1 week's worth of data, then it tends to be a much smaller slice of that data. And so I think that, people do sometimes have larger amounts of data, but typically just the way they end up using it, you don't need giant amounts of data. And as I mentioned, like that, big data is more than what you can process on one machine. These days, actually, commodity machines on AWS are, hundreds of cores, more than a terabyte of RAM. And, there's not a lot of workloads that don't fit in that, that amount of hardware. And so, whereas like 10 years ago, 15 years ago, it was like the largest EC2 instance was a couple of gigs of RAM and like 2 cores. That's a very different world than we're living in now.
I think, as you mentioned this, I mean, this has been, I believe you started MotherDuck about 3 years ago. Is that correct?
Yep.
And I feel like we're now seeing this from the compute side of AI, where a lot of people have been operating under the assumption that really the only solution to move forward is to add more compute, bigger machines, more machine, bigger context windows. Now, I mean, we're seeing we need more energy. Therefore, we need to build the craziest nuclear plants. Like, it seems like there is a part of us, actually, and Upal and I have been talking about it a lot, is there a paradigm shift where this conversation is going to be moot 2-3 years from now, when we realize that the compute necessary to process, like, number one, do people actually need this? And number two, is the compute necessary to, do proper inference? Is it going to be much, much smaller than it is today? Therefore, we're not even talking about nuclear plants, right? I wonder if there has been an evolution in the last 3 years, probably before that, but in the last 3 years, where you've seen people shift a little bit their strategy and think, oh, maybe I don't need a massive machine to process all this data because I can just do it in byte pieces.
There are a handful of people that do get it. And when I published a blog post called Big Data is Dead, and I talked about a lot of these things, and sort of the reactions I got to that, some people were like, well, of course, big data is dead. Everybody knows that. Some reactions were like, no, you're crazy. That's not true at all. Some people were like, oh, I've got big data is dead, but I've got big data. And then there were some people who were like, wow, you're speaking to my soul, like this, because I thought that I was the only person that didn't have a ton of data. Like, there was a lot of maybe imposter syndrome in the data industry, where people were like, oh, I'm not a real data analyst or data scientist or data engineer, because our data sizes are much more modest than everybody is talking about. And that's one of the things I tried to do with that blog post, was just to sort of normalize the dealing with actually the size of data that that virtually everybody has. And I think it's especially interesting in the in this AI era, where as you mentioned, models are getting bigger and bigger and bigger, and the amount of hardware you need to handle those are getting bigger and bigger and bigger. And the similar with data, like you throw more hardware at it and it's more expensive. And there's a point where people are like, there's a lot of money to be made by doing things with less data, doing things with smaller models, doing things with less hardware. And in the data world, we've seen that, really work out well. And as I think the better a query engine is generally, one of the signs of it is it's able to do its job and read less data and do less, to do less work. Better optimization means you're going to do less work. And I think in the AI world, I think we're also seeing that, hey, you may not need these giant models. And I think there's a lot of energy being put into, smaller and smaller ones that you can fit, on more modest hardware.
This happens to us a lot, because I always tell the people that use our software that our models don't need to build you poetry. They just need to be very, very good at transforming messy data into structured data. And so we have an incredible opportunity at just actually, either through distillation using open source models or something similar, to actually go further into the smaller we can fit, the better.
Mm-hmm.
Especially because a lot of our customers have said, well, I want to run it on my infra, whatever. Maybe there was some compliance issue. Maybe we're talking about security or IP. Great if I go to them and I say, well, yeah, you'll pay us X much every year for license. But like, by the way, the infra, since now you own the compute, is going to be $500,000 a year. That's a very different question, right? So there's equal parts like, is it practical? But also, is it just too expensive to even run, right? Speaking of big data is dead. I was actually really curious. So you brought it up yourself. I mean, obviously, that blog post, you got a lot of different reactions, right? Are there any specific areas where big data is not dead? Like, have you been proven wrong in specific areas where you said, you know what, these guys actually do have petabytes of data and they need to process it all at once?
There are certainly people that have giant amounts of data and that need to process that over and over again.
Yeah.
I think those use cases are getting fewer and fewer. Like there was the folks that who work on Redshift published a paper last year where they talked about a bunch of things, and they provided a data set of like query logs from a bunch of representative Redshift instances.
Yeah.
And so I was able to look at that and realize, hey, most of the the vast majority of these don't have a lot of data. Most users never process a lot of data. Most databases, like the instances never process a lot of data. But of course there are the cases where people still do have giant amounts of data. But I think the other thing is, if those, like, what do you design for? Like, as you're building a system, do you design for like the thing that you're doing over and over again, or do you design for the thing that you do in the 1% of the time? And I think that's the switch that I'm hoping to help usher in. Is design for the thing you do over and over again, and then make sure it works on the thing you do 1% of the time versus the opposite. Because when you design for that 1% of the time, like the main case that you care about is not going to be optimized, is not going to be as easy to do. And as long as you can still do that, if you focus on the common case, as long as you can still do that the other stuff, then you should be in good shape.
I guess it's overkill for most use cases to have massive amounts of compute. I wonder if I can see it from a more perverse incentives perspective. I wonder if there is a perverse incentive to use big data as a marketing crunch and saying like, well, it's insurance. Like, well, what if you need it for 1% of your use cases, right? Like, what's going to happen then? And I wonder if that's blinded. I equate this to the buyer versus the user, right? Does the actual data engineer know their workloads and what they need? And does the buyer and the signer of the contract actually rather say, you know what? Let's give ourselves a little insurance,
I think that, makes a lot of sense that, the buyer doesn't want to have to do another migration. And so they may over provision, they may buy more than they need to. But I like to think of it as a little bit like, the early days of electric cars, and there was like range anxiety, and it was like, It's like, well, I never actually drive more than 30 miles at a time, but 2 years ago, I went on this road trip and, we were doing 500 miles a day, and I need to make sure that I can still do that. I think over time, people have gotten much more comfortable with the range in electric vehicles. And yeah, there still are, internal combustion engine vehicles. And some people are like, well, I have one of each so that I can go on my road trips with the, my gas SUV. But then I also, like, day to day, I drive my electric vehicle, and it works great.
Yeah. The range question is fascinating because when you actually look at it, you promote any kind of car that has below, let's say, 250 miles of range. And people are like, well, that's unusable. Right. And the reality is 250 miles of range is quite an incredible amount of range for everyday use, especially if you live in a metro area.
Sure.
you're doing 20, 30 miles at a time, unless you have a big commute. And so I think it's a very similar thing. I wonder if it's psychological almost to think, well, I want to have the extra range, the extra compute, the extra everything.
Yeah. And I think that's true. And I think, in order for, Teslas to become mainstream, they needed to build this, this nationwide infrastructure to allow people to go on these long road trips. And I think, I guess what's the sort of big data equivalent of that? I think it's making sure that, you can actually operate on larger amounts of data, because I think that generally, like, if you just think about what's happening, you have a single machine and then you have data that's stored on, generally object store.
Yeah.
Like as long as you don't mind waiting a little bit. And I think that's the same thing, you charge your Tesla and you have to wait like 30 minutes for it to charge. As long as you don't mind waiting, like a small instance, compute instance should be able to handle virtually any workload. It's just, it's got to pull data into memory, do some computation, flush stuff back out. But, generally good query engines can handle that. And DuckDB has gotten quite good at that over the last couple of years.
I'm really curious, now that you bring up the subject, I wonder if it's also a matter of UX and access patterns for the developer. I actually had a question for you regarding, you guys have obviously made design choices, right? And one of them is this sort of hybrid architecture.
Mm-hmm.
Was that decision more based on the access pattern for the developer, more like the ease of use, like the workflow of the developer, or like, is there a functional part of it as well?
It's a little bit of both. So first of all, like one of the things that DuckDB does really well is it makes it just simple to use. You do pip install DuckDB, brew install DuckDB. You're in Python, you do import DuckDB, duckdb.connect.sql, and you run a query. And it makes a lot of things really simple for developers, whether it's inputting CSV files or Parquet files or whatever.
Yeah.
And we wanted to make sure that we were going to live up to, that standard that DuckDB has set. So how do you do that? Well, one way of doing that is to make it so that if you're using DuckDB, like all you have to do is change the database name and now you're running in the cloud. And so kind of we built this integration. And so how do you do that under the covers? Under the covers, the way we built it was, we built this hybrid system where there's a local DuckDB and the local DuckDB does the parsing of the query, but then actually we hand that off, we send that to the cloud. We can even, and let's say you want to load data into the cloud. Well, you can do the parsing locally, or you can have a local DuckDB database or local CSV file. And then it's just a, read from this file right to this other one, this other database that's in the cloud. So we wanted to make that just sort of super seamless and easy to use. And so the hybrid mode helped us sort of make it super simple. The other thing that it did was it enabled new things. And so, I think hybrid is not really a feature so much as a platform on top of which you can build other features.
Yeah.
Like you can build like these user interfaces that, are 60 frame per second data visualizations, because you're doing a bunch of the work locally and then you're doing other parts of it in the cloud. Or, we built a Postgres extension that hosts DuckDB inside Postgres, which is great for analytics. But on the other hand, like the local analytics, the DuckDB engine is going to fight with Postgres for memory and CPU network. Yeah. And so what we can do is we can then use that same mechanism to offload that into the cloud into MotherDuck. And it's just all the same. It's that same platform. And, to some extent it was just sort of like a hunch that this is going to be useful. Because, in building BigQuery, we kept running into a bunch of cases where we wished we had a local query engine so we built the ODBC driver, which lets people who are writing code connect to BigQuery. And they're like, there's a bunch of like query transformation stuff we wanted to do locally. It's like, no, we can't do that locally. And there were just several things that would come up. And so as we were kind of designing the initial MotherDuck architecture, it was like, if we have this opportunity to do this, it's going to open up a bunch of possibilities. And we have an idea of what some of those are going to be, but some of them we haven't even thought of yet, which, the PG DuckDB, the Postgres extension wasn't something that was in our minds at the time, but it's like, hey, this works. And there's been a couple other things like that. It was like, hey, this is actually enabled by the architecture.
I think that makes total, I mean, as a developer, when I read that and I think about it, I'm thinking about not just flexibility of workflow, but also now the access pattern is such that I can do proper CI/CD in a way that is not going to like break my mind and think, now I'm pointing to our like cloud instance, and now I'm pointing to this other cloud instance, and I have to spin up a new one. And I think it's flexibility. I think that I've been thinking a lot about this with the advent of the like vibe coding and these platforms. I actually use V0 to prototype. Mm-hmm. And funny enough, I use it as a Figma almost. I wish it could actually produce Figma documents instead of websites. But I also, now you can deploy the things that you make on V0, but there is just something there about the access pattern. If I'm trying to build a production application that is missing, mm-hmm. And it's hard for me to describe in words, but if I'm an engineer at a company that is shipping production software, then I'm thinking, great, what does the CI/CD look like? I can technically now push the code to GitHub, but is that different from just writing it myself or writing it statically and then pushing it? And so I feel like any little tidbit of flexibility that you can add. I mean, I was thinking about your guys' architecture and equating it to, for example, when serverless TM as a concept came out, and AWS and GCP, they all like kind of embrace this. The truth is, and maybe that this is a little bit of a hot take, but to this day, building and coding Lambdas is actually not a beautiful experience as a developer. The experience of me running Lambdas locally versus pushing them into the cloud feels completely detached. Mm-hmm. There's Lambda layers. There's a lot of gotchas that in order for me to seamlessly run as part of my workflow would be too hard. And so I wonder if at the end of the day, what you guys build is essentially a way to acknowledge, hey, this access pattern is necessary because there needs to be some flexibility.
Yeah, and I think, you mentioned like CI/CD and prototyping, and I think that's one of the nice things is that, we let you, people can prototype using DuckDB. They don't have to use MotherDuck or know about MotherDuck at all. They run something on their local laptop in their development environment. They set up their CI/CD platforms. But then moving into production is just a case of changing the database name. So if you add the prefix MD:, and provide an authentication token, then everything runs in the cloud. So the moving from kind of the development environment to production, which I think you were saying was actually can be quite difficult dealing with some of these like serverless systems. We make it super easy.
Yeah, and it's happened to me. I mean, I don't know if you guys have been exposed to this, but I'm a big fan of TypeScript. I'm a JavaScript cowboy. That's how I started coding. Upal kind of hates me for this, but I do like JavaScript a lot. It is very flexible. You can also code a lot of terrible things with it. And one of the things that I run into when I was using, for example, Prisma, is that Prisma as an ORM, the experience of using Prisma locally is very, very different from trying to deploy it into the cloud, mm-hmm. and specifically in serverless environments, to the point where Prisma themselves as a company have built things to make the workflow a little bit more flexible. And so it's interesting that you guys sit at a very interesting, in a very interesting juncture where you do have that freedom to say, well, storage and compute are very different things. They can live in different places as long as that gives you flexibility of access pattern, right?
Yeah, and I think there's another like kind of just architectural change that has been happening recently, which is that laptops have gotten a lot more powerful. Like that Mac yes. that you have right there, like that's more powerful than most server computers. Just a few years ago, like there was George Fraser, the CEO of Fivetran, did some benchmarking of DuckDB on his laptop. I think it was like a 2-year-old laptop at the time against a cloud data warehouse that must not be named Uh, and DuckDB locally on his laptop was faster. And and it's maybe not surprising these days. Like, yeah, it's a super powerful, machine with really fast disk and, all sorts of like nice things. But it's the way people think about, the way hardware and cloud, and, versus local and edge, the way people kind of engineers have built an intuition around those is the intuition is, okay, if it's on your laptop, it's slow.
Yeah.
And it's almost oh, I could run that on my laptop, meaning it's kind of trivial. And I think you're seeing the same thing I think we will be seeing in AI where, people will be downloading models to their laptop and like being able to do things much faster and much more naturally. So I think that there are going to be some interesting new paradigms that open up. And the other one is, the other enabling part of that is, faster networks, people having, gigabit to the home and like super fast networks. So it's like, yeah, if your data is only medium size and your model is only medium size, like, yeah, you could probably just pull that down. And the thing you don't want to have to necessarily do is worry about sort of managing it and downloading it every time or downloading. And so, for tools that can make that seamless, I think there's a big opportunity to build better experiences for users.
Yeah, I mean, you were mentioning yourself, like with my laptop, I run Olama, for example, and you can just run decent models, not too big, right? Like I get it. Or even on my iPhone, you can run like distilled, like 2 or 3 billion parameter models pretty easily. And for us, because we are not, like BEM does not make its own models. We do a lot of fine tuning, we do DPO, but we don't build our own models. There are people that are much, much better than us at like building models from scratch. But that also means we get to sit above that and move the needle whenever we need to. And so for us, that hybrid approach is really relevant because even ourselves, I can run our BEM dev environment on my laptop and just point it at Olama if I want to, or just choose to point it at the cloud, our own instance. And so that adds a lot of flexibility. We've talked a lot about DuckDB. I'm really curious, and I know this is even more relevant today because of the advent of AI, or let's call it like the last generation of AI. MotherDuck has DuckDB at its core. I'm really curious what it feels like and what it's like to build a company with open source at the center.
So when we started MotherDuck, we wanted to make sure that we weren't just taking a popular open source project and say, hey, we're going to thank you for building this. We're going to now make a bunch of money or try to make a bunch of money off of it.
Yeah.
So, we gave them a co-founder share of the company when we started, and, also, built this agreement with them, which, where, we help fund the development of core DuckDB. They, build features for us. They agreed not to, work with anybody who's going to compete with us, and kind of forge this really nice partnership that, sort of like at the very beginning, we're like, well, this only works if we trust each other. And so we have to sort of forge this relationship that, like any close relationship requires work.
Yeah.
And especially, because sometimes interests diverge, et cetera. But I also think that like, so far it's been working out super well. They get to focus, the DuckDB founders have a company called DuckDB Labs, and they get to focus on building an amazing database, an amazing open source database. And that's their goal. They don't have to deal with, a lot of the stuff that, being a venture-backed, company that you have to deal with. But, on the other hand, we get to, some of the benefit of that. So we sort of like have this nice kind of separation of concerns. And I think if this works out, and hopefully it works out, then it will be a model that other people use, because people keep talking about like how do you build sustainable open source, and you see all these cases where commercial companies that are building open source, as time goes on, their commitment to open source starts to dwindle.
Yeah.
And then this is a way where if we told Hannes and Mark, hey, like you need to change your license, they would tell us to, go to hell.
Yeah.
It's like, whatever, like, no, like, we're not, I mean, like, it's written into our bylaws that we cannot do that. And so the community gets, the guarantee that this is going to continue to stay open. At the same time, you can have sort of a venture backed funding model where, yes, we have more ability to, fund development, fund marketing, fund engineering,
Yeah.
and all the things in a growth company, without necessarily polluting or even being able to pollute the open source.
No, totally. And I think that the way that you guys have both the partnership and also the functional aspect of things feels very modular. I'm wondering do you feel like the market, when I say the market, I mean, being a VC-backed company, do you feel like the market understood that relationship, or has it taken some time for VCs to kind of get it? Because it's a fairly different kind of flavor from what we've seen. There's companies that use open source as a distribution channel and then sort of taper out of it. There's companies that, as you very well said, take open source projects and just rebrand them and just, create a cloud managed system out of it. As an engineer, this feels more sustainable. I'm wondering if you feel like VCs got it.
I don't think they did, or some of them didn't. Some of them, did, and I guess continue to approach, the DuckDB Labs folks is like, why don't you guys go build your own company? What do you need these MotherDuck, folks for?
Yeah.
And other people, as we were pitching, they, they're like, well, it seems like, what happens, they worry about contingencies, and they've also seen a lot of things go bad and seen, open source projects go bad. And so they get nervous about what happens, when something, when the relationship starts to sour. And in fact, one of the people that, I talked to, one of, the CEO of Databricks, as a reference when I was doing my Series A. And he said, what's going to happen is, at some point, your interests are going to diverge. Maybe it's maybe it's because, AWS will have a hosted version, and the open source guys, they're going to be like, hey, this is amazing. All these people are using the software that we're building. And meanwhile, they're eating your lunch, and making it difficult, because, that's basically what happened in, the Spark Databricks story. Didn't necessarily prevent Databricks from being successful or making money, but it was certainly created tensions. And so far we haven't had to deal with that. And this, I think, because by, actively managing the relationship and, and making sure that we that we like each other and we like working with each other, and that we all see that we're getting something out of it.
I wonder if there is a aspect of things, and I've noticed this in recent years, that the industry has become more and more transactional. And I wonder if really the hardest part about this kind of partnership is the human aspect, right? Like there is the functional aspect, but there's also like the nuance of building a relationship, building a sense of mutual trust. Like, I wonder if the industry is not understanding that kind of, I say that vocabulary and it feels like, oh, I don't understand what you're talking about.
Yeah, well, I think, sometimes it's easy to underestimate the, the value of sort of personal relationships and the sort of the human side of building a company. And I found like that, as I started my career as an engineer, and like, I loved that you could tell the computer what to do and it would do exactly that. And like, you could get these dopamine hits every time, you got something working. And then I think you sort of, you get to a point where you realize, well, in order to really be able to build something bigger than I could just build myself, that it then becomes a human problem. And how do you, marshal human, resources and people to help you build the vision that you have, or the thing that you have in your head. And that becomes so much harder, because people, they don't do what you tell them to do. They all have their own interests. They all have their own, like, ways of approaching the world. But I think if you kind of can align things right, you can build something that's kind of even bigger, better, and richer than you could have conceived on your own, because they all have like the things that they're great at and the things that they can do and they can envision, and you just sort of need to like point things in the right direction.
I keep thinking about moats. Software companies get asked this all the time by investors, by recruiting candidates, by like everyone, and I feel like there is people that get this and people that don't, but I do feel like there is tremendous value in infrastructure, and there is tremendous value in UX. And I feel like, in a way, MotherDuck has managed to create this really, really good access pattern for developers to actually use DuckDB. You know what I mean? And it's not to sell you your own company, but I feel like I wonder if you guys have run into the mode question. I mean, we've run into this too, because we don't build models. So the first question is,
Sure.
well, what are you guys doing here? Like, anyone can just build what you guys are building, right? And so I wonder if you guys have run into this.
So we do get the mode question. I think but that's also one of the rationales that we had for this hybrid execution mechanism, which is even if let's say Amazon wanted to replicate MotherDuck in the cloud. Well, if they wanted to replicate it exactly, they would essentially have to replicate, not just host DuckDB in a Kubernetes instance somewhere, but they would also have to figure out how do we split query plans, local and remote. Yes, they could, DuckDB doesn't have a REST API. So they would have to figure out, okay, well, how do we do this? Also, let's say they were able to do all of that. Well, it wasn't going to be called from every, so DuckDB wouldn't be able to talk to it because we have that sort of built-in mechanism. And so there's a bunch of these things that they would have to add. First of all, second of all, DuckDB it's an embedded database. It's not it's not a full-blown data warehouse. It doesn't have any concept of a user. It doesn't do a lot of, concurrency has some limitations. And so a lot of the work in MotherDuck has been, building out some of those things, making it so that you can have, read concurrency and write concurrency. And so AWS would have to build all that stuff. I mean, yes, they can. They have a lot of engineers. It's just code, but it's also not. It's not the same as just say, hey, we're going to take this thing and we're going to stand it up and have a competing service.
No, I think that makes total sense. On that note, I'm really curious. So I've read some of what you've written, and I believe in one of the blog posts you were talking a little bit about performance and how designing for performance or exclusively for performance is sort of a bad way to choose a database. And I'm really curious on that note. I'm sure you've seen, being in the database world of things, I'm sure you've seen this new wave of database companies that have sprung up from the vector sort of and RAG use case, right? And there's a bunch. There's Chroma, there's VBA, there is Pinecone, there's Qdrant. A lot of them focusing on vector storage. And I've noticed that the way that they try to differentiate themselves, at least at face value from what I can see as a user, is performance. I'm really curious how you guys think about performance and how you think the idea that, designing for performance is or exclusively for performance can be a bad thing.
First of all, it's very difficult to rank two databases in terms of performance, because so much of it has to do with the workload that you're running.
Yeah.
And there's benchmarks, but there's a lot of bad benchmarks, and there's not a lot of good benchmarks. And so sometimes people put a bunch of these benchmarks together. For example, there's the TPC group is a consortium that put together a handful of benchmarks, but they're based on sort of the architectures of data warehouses, I would say, in the 90s. And, that may or may not be relevant to kind of modern, web logs or real-time data, or kind of generally the way people arrange their data. In fact, Redshift paper that I talked about earlier, the purpose of the paper was to talk about, hey, the access patterns in these TPC benchmarks don't actually match what we see running in Redshift. So performance is so dependent on workload, and I'll give you a good example. Like let's say you have two databases, and one of the databases is 50% faster on 90% of queries, but then on the other 10% of queries, it's 100 times slower. Which one of those databases is faster? Well, if you sum up the times, the other one that's 100 times slower probably would take more time in terms of actual user experience. If you needed to run that one query and you had to wait 100 times as long, like the users are going to be upset. They say, hey, no, we can't even use this database at all. I don't care that it's faster on these other queries. Whereas, like, let's say you were able to rewrite that query, so you didn't need to run that query. Then the other database would be twice as fast. So it's like, it's so workload dependent. And so like one of the other things I noticed in working on BigQuery was we had this feeling that, we were fast, and then people would run benchmarks and we would actually be quite slow. And it's like, hey, the lived experience doesn't necessarily match the benchmarking experience. And then so people would publish these benchmarks and we would get our butts handed to us. And we're like, oh, wow, we're never going to sell again, against, these other data warehouses that are clearly faster on this benchmark. And nobody cared. And in fact, like if you looked at the stack rank of the fastest database to the slowest database in those benchmarks, the sales were kind of in the opposite order. So it's like the slower databases ended up selling more. And I think it's because that all of the other stuff around them is the ecosystem. It's the, one of the good things about BigQuery was that it was able to kind of make forward progress on just about any query. So people didn't really have to worry. It's like, okay, maybe everything's a little bit slower, but I never have these queries that go off into the weeds.
Yeah.
And so sort of like, when I was working at SingleStore, like our claim to fame was performance. And it was such a single-minded thing that it sometimes got in the way of like, okay, what's the right architecture and how do we make this easy to use? And there's, other databases out there that, they seem so focused on performance that like, the way they write the code is they, hand code every, in assembly, like, so they could do vector instructions and all these things. Whereas like the DuckDB folks, they wrote the code very carefully so that the compiler would vectorize it. And it's like, yes, they probably could have got eked, another 50% more out by, hand coding that. But on the other hand, like when the new Apple Silicon came out, they got it to compile in an hour.
Yeah.
Versus like having to sort of rebuild everything for it. And so portability, usability, ability to maintain the code, ability to like actually add new features is important. Because I think one of the other things is like the performance that's important may not be actually how fast your database is, but how fast your database is getting better.
Yeah.
Because like in general, people make decisions about hardware platforms or software platforms, that have several year time horizon. You don't want to like change your database every 6 months. And if, one database is 10% faster than the other one, but the other one is getting better, 3 times as fast in 3 years, like they're not even going to be close. And kind of, so that was sort of the bet that we made on DuckDB was we looked at like just how quickly DuckDB was getting better. And it's like, wow, this is the horse to bet on, because like they can move so fast and they can get stuff done so fast. And the other nice thing is like DuckDB is quite fast. You look at, benchmark results, DuckDB often beats most other competitors, but I think it's just always dangerous to sort of pound your chest and to be like, oh, we're so fast, because if that's where you derive your sense of self-worth, then as soon as somebody like can beat that performance, then all of a sudden your reason to exist is just sort of gone out the window. And chances are that's not what the users wanted anyway.
Yeah, I wonder if they're commoditizing themselves in a way by just they're playing a game that someone is going to beat them at, essentially.
Yeah, and I think it's you don't want to be racing to be the fastest. You want to be racing to sort of do things that nobody else can do or in a way that other people hadn't thought of before. And so if you spend your energy figuring out how do we make this a richer, more, better, easier to use platform versus how do we win this race, then you're going to have, then users are going to flock to what you're doing. Or at least that's our hope.
No. And I think from looking at how you guys have built MotherDuck, it seems to me from an outsider's perspective, would it be correct to say that you guys care about simplicity?
Yeah, 100%. We want it to be, the easy thing to do. In fact, the code name we had internally was Easy Query.
Easy Query, yeah.
Because it's we just want to make queries easy. You send your query, it runs, it's fast, it's simple.
So speaking of simplicity, and you can actually see this when you go to MotherDuck's website. You guys have a diagram of where MotherDuck fits in a data stack. I'm not a data engineer. I'm very much a software engineer. I'm actually very bad at data engineering. It seems very complex to me. Not the MotherDuck piece. When I look at the entire diagram and all of the tools and the ETLs and the reverse ETLs, I think I've heard you talk about how, I don't know if you used this metaphor exactly, but does it feel like a Rube Goldberg machine a little bit when you look at the entire market of all these ETLs and pipelines and everything? Is there a way that we can simplify all of this, or are you guys working towards simplifying it?
I do think that the complexity of the modern data landscape has sort of gotten out of control, and I think things. I think part of the issue is that people kind of have focused on sort of more and more narrow slices in order to carve out their own niche. That now we have all these narrow slices, and if somebody wants to build a basic data stack, they have to pick and evaluate a dozen different pieces of software. So far, the market has, I think, resisted a lot of consolidation.
Yeah.
I think the obvious thing that would be to say would be oh, I think the market is consolidating. And I think there are best in class in each of these things, and I think probably the best in class is gonna win, and then maybe we'll see some consolidation. I do think that if you're looking at if you're a giant enterprise, which is where the majority of the money is, then you can evaluate all these different things and data governance and ETL and reverse ETL and observability and all these transformation pieces that you need. But for smaller companies, that's they don't want to have to deal with that, and so I think that there likely is going to going to have to be able to figure out at least at the bottom end of the market how do you build something simpler.
Yeah,
and I think over time, if you can build something simpler, then I think that can work its way up the food chain. But I think ecosystem is so key in the business, is because people have their set of ecosystem tools, and if you want to play nicely, you have to sort of fit in with your niche, which I think is one of the other things that harms consolidation.
Yeah, and I think there is value in having these modular pieces that you can weave with one another, for sure, right? So consolidation, I guess the issue with consolidation is that as a company, you have less optionality and maybe perhaps less ability to customize, so to speak. I think for us, the funny thing is most people still can't place us in the map. And we get investors ask us, when we started pitching them, the first question was oh, so you guys are like an ETL. And I'm like, no, because all of the data we ingest is it looks insane. You can't put that in ETL. It's literally the most unstructured data you can think of. And they're like, oh, so are you competing with MotherDuck? And we're like, no, we're not a database. We're not we don't store. We are actually very adamant with our customers that we don't want to store your data. You have databases for that. And so I think it's interesting for new folks coming in. It's actually been hard for us to like, very technical people will get it. They're like, got it. Yeah. Like I can't pipe into like an ETL data that it's not even fathomable. Like it's not even JSON. It's not even Parquet. Like it's just an array of bytes basically. But I think it's really interesting that I wonder if some of the areas of that market have been defined by the industry as a whole as a means to sell rather than the like actual functional aspects, right? Like to me, a lot of it is there's certainly pipelines, there's certainly connections between the data, there's compute, and then there's storage. And everything else kind of starts blending in and there's flavors of that. But I wonder if we've purposefully, as an industry, created this complexity spiral in a way. And maybe the complexity spiral sells. I don't know.
Yeah. Well, I mean, at some point, in a complexity spiral, things just sort of collapse under the weight of their own complexities. Like, nobody can deal with any of that. And like, just give me like, bytes on a Parquet files on EC2 and, we'll call it Iceberg and, then we can all work on that.
Yeah. No, we've done this a couple of times. The same prospect that asked us, how do I connect you guys to our ETL and reverse ETL? And if the Salesforce data is flowing from this point, where do I put it? Where do I put them? And the same customer then said, can you guys just read files from EC2? And I'm like, great. Like, it seems like you came to the conclusion by yourself, you've built things at Google, you've built things now at a startup scale. What advice do you give to founders today that are building new primitives, new abstractions, new software?
I think one of the things is you kind of have to have your own take on the world that's a little bit unconventional.
Yeah.
I think if you there's a handful of ideas out there that are sort of, I won't say obvious, but it's sort of like the conventional wisdom is sort of leading us in this direction. And I think if you're building something based on conventional wisdom, you're jumping into a competition pool of people who are generally well ahead of you. You don't have any advantages.
Yeah.
And I think if you can kind of figure out something about the world where the thing that you're arguing for is kind of against conventional wisdom, or is something that based on something that is actually, things are going to take this other track, then I think that's where you can really have leverage, and that you can really have kind of an advantage against the incumbents and against the other startups out there. Because if everybody's like, hey, we're going to go, play over here where everybody says, is the next big thing. And you're like, well, because of all this other work that I've done, I kind of know that actually this area over here is fertile, or is where there's an opportunity. Then you have the chance to sort of stake that out on your own. And so my urge to founders would be, find that nugget of sort of unconventional wisdom, and where you can sort of build your own thing. And then the other thing is, then you have to be able to connect it to what people know and what people expect. Because if you just build something that's sort of like totally weird, then that's also not a great solution either.
People still, not everyone, but people still call us stupid for saying that we don't build agents. And I'm very adamant that BEM is not building AI agents, but I feel like for us, that is the bit of unconventional sort of take on the market, is that we actually think agents don't work for most use cases. A lot of people disagree with us, especially investors.
But then if you're right, then like you get, you have all this area all to yourself, which is, good, but it just means you have to have the conviction to sort of hold the line.
Yeah. Yes. And it's been harder than I thought. I mean, I was telling Upal and I had a very close to our hearts one-on-one yesterday, because I think we're both a little bit burnt out from the noise in the market. It was always the case, but I feel like in the last couple of years, you open LinkedIn and you have 1,000 opinions and everyone has an opinion on something. And, I told Upa, like, I feel like they always tell you as a founder that don't allow yourself to be distracted by the noise. I never, I've been a founder for about a little bit over 10 years, and I've never really been in a situation where I'm like, honestly, the noise is getting too loud and it's starting to wear on me. And maybe that's what people actually mean. Like, it's easy to ignore the noise when the noise is stupid, but when it's starting to wear you down, then that's when you're like, oh, I'm actually burnt out from like hearing all these talking heads,
I mean, the AI space is there is so much noise and so much froth and so much like, this is what's happening. And then, no, this is happening. And then like, so I'm glad that we're a little bit removed from that.
You guys are just an incredible. I'm very envious that you guys get to be in the source of truth industry as opposed to like, this new AI industry. That's really, really awesome. I have a rapid fire round of questions for you.
Sure.
Some of them are sillier than others. And so, one question for you, and whatever comes to mind, we don't need to overthink this, but one question that I have for you is, what's one database trend that makes you roll your eyes?
Oh boy. Open data formats. That's quite controversial, but yes, I think a lot of the reasons that people are going with these open data formats are not the reasons that they were created in the first place. And I wonder if there's going to be a backlash.
What's a tool that you secretly love, even if it's uncool?
Omni is our BI tool, which is very. I spend a lot of my time in Omni.
You guys don't use Looker? I mean, how dare you?
But it's a lot of the people that created Looker are the ones behind Omni.
Okay. That makes total sense. What is one word that your team would use to describe you?
Ooh, this is getting personal. I don't know. Tempted to say asshole, but I don't actually think that's true. But uncompromising.
Okay. That's a really fair. It's better than asshole for sure. What's a hot take that you're not sure you believe, but you kind of wish were true?
Well, I think actually open data formats is one, because if everybody moves to open data formats, we're going to be in actually really good position, because people can start moving their data out of their existing data system into Iceberg, and then we have the same access to the data that Snowflake or Redshift, et cetera, do.
It sort of removes lock-in a way.
Exactly.
Yeah. And the final one is, if you can finish the sentence, which is, in 5 years, the best data platforms will be
MotherDuck. Yeah, I think we'll be hybrid, local and cloud.
It makes total sense. Which is more on the UX, on the access pattern. That makes total sense.
Yes.
Jordan, thank you so much for doing this. I really, really appreciate it. Any parting thoughts? What are you most excited about next? What's next for MotherDuck?
We have some really cool stuff launching at Data Council. And so I'm excited to see what the reaction is to that.
Okay. Well, I'm excited about that too. Thank you so much, Jordan. I really appreciate it.
Appreciate it.